Okay, good morning to all of you. In this class, we are going to start to discuss about special continuous probability distributions. Okay, in our last class, we have been discussed few numericals about multinomial distribution. Before that, we have been discussed in detail about moments and moment generating function of multinomial distributions. In detail, we have been discussed, and this was your last topic of your discrete distribution. Okay, so here from this class onwards we are going to discuss the continuous probability distributions. So as per your syllabus we are going to discuss about normal distribution, uniform distribution, gamma distribution, exponential distribution, chi-square distribution, beta distribution. These continuous distributions are inside your syllabus. So we are going to discuss these continuous distribution. So first we have to start from normal distribution. Okay, and one thing you just recall that for discrete we have to consider PMF, probability mass function, and for continuous the distributions are represents in the term of PDF, probability density function. Okay, so let's start to discuss about normal distribution. Okay, any dynamics in our surrounding having n tends to infinite, that means trials or observations. If we are going to consider infinite numbers, that data will be follow the normal distribution. Okay, so here two three examples are there. You can see throughout the day our energy level. You can see if we are going to consider our energy level, this is our throughout the day from morning to night. Our energy level increases gradually with time, and a particular time it will reaches the maximum, then it will decreases at the end of the day or at night. Okay, so this is so called your normal distribution. So this along this axis we have to consider the time. Either you have to consider each and every minute, or you can consider each and every second. So throughout the 24 hours the distribution of the energy level will be like this. Okay, and we can consider another example, that is your plant growth of the plant. You can imagine that the growth of the plant, suppose one coconut tree is there. Okay, so the growth of the coconut tree or any tree generally according to biological point of view, it is increases with a faster rate up to some month or some year, and it will reaches its maximum growth rate. That means from starting point the uh, rate of growth the rate of growth increases and reaches at the maximum, then the rate of growth gradually decreases and it will touches the zero. That means a plant or tree has been growth, or you just consider the growth of the plant. It will be continuously increase its height with this growth rate. That means the growth rate initially increases, reaches the highest, then decreases, and at last there is no growth. That means suppose you are going to consider this is your coconut tree. Initially the growth rate will be somewhat increases, and at a middle of the time it reaches the highest, and then the growth rate gradually decreases and it will be the constant height after some year. Okay, now you can consider any business. Suppose we are going to consider one business that it is started, or we are going to analyze the throughout the year. If I am going to analyze my business, then sometimes I got the profit, and sometimes I will be get the loss. So if I'll be consider the profit, so if I'm going to consider the this along this axis my profit, and this axis my throughout the year time, then the profit at some month, at particular month it is maximum, and before that and after that it is gradually decreases like this. That means I can get the minimum profit, then it is gradually increases and touches the maximum, then after that particular month it is gradually decreases. Okay, that means if I will distribute the month or time with respect to my profit. Okay, so likewise you can consider the, so another example you can consider the COVID cases. So now the third wave is running, right? Now the third wave is running, but you just recall the first wave and second wave. When we faced, we got what, the the cases per day increases, reaches the maximum, and then decreases. Even if second wave also same trend we found, right? So this is the, that means in a particular period the cases, COVID cases increases, reaches maximum, then reaches maximum or peak, and then decreases. So likewise any dynamics can be represented with the help of normal distribution. So here the basic definition of the normal distribution is that, or a random variable x is said to have a normal distribution, or random variable x is going to be follow the normal distribution with parameters mu, that is its mean. Okay, uh, and sigma square, that is its variance, if its PDF, that is your probability density function, if it's a PDF, probability density function, no need to write because we know that this is a common uh, abbreviation for the statistics. So its PDF is given by the probability law, or the PDF is represents as f x, such that mu sigma equal to 1 by sigma root over of 2 pi into e to the power minus z square by 2, and the this z value can be vary from minus infinity to plus infinity. So this is z. Okay, z only, z. So this z can be vary from minus infinity to plus infinity, and here z is called as your normal variate, and z can be written as in the form of mean and variance, mean and standard deviation. Okay, so here sigma square is represents the variance, so sigma will be obviously the standard deviation, right? uh, that we know. Okay, and that means the sigma will be here, sigma is the root over of variance, or that is your standard deviation. So here z will be equal to x minus mu by sigma. So by considering this z value, the PDF probability density function will be 1 by sigma root over of 2 pi into e to the power minus, here instead of z we have to put this one, x minus mu by 2 sigma square. So here x minus mu square whole square by 2 sigma square, and here x is going to be vary from minus infinity to plus infinity. Okay, and this is your so-called PDF. This is also called as the PDF. Here pi value we know that 3.141, and exponential value 2.718 are the mathematical constant. And in short we can also we can write that this random variable follows the normal distribution, having mu is its mean and sigma square is its variance. So x such that n represents the normal distribution, mu sigma square. Okay, this normal distribution also called as Gaussian distribution, because Gaussian, another mathematician, has been published some papers by using normal distribution. So as per his name, this is also called as the Gaussian distribution or bell shaped distribution, because I told that the distribution, normal distribution, will be like this. At a particular point it will touches the peak, and before that, after that, uh, it is decreasing and decreasing, so it is looks like a bell shaped. So only for that, this is also called as the bell shaped distribution. And here mu is nothing but your expectation. Mu is belongs to your expectation of x or mean, and sigma square is nothing but variance. Okay, variance here I written, no problem. Now we have to consider the graphical representation of PDF of normal or Gaussian distribution having different mu and sigma values, having different expectation value, having different mean value and standard deviation. So here first we have to consider different mean value and same standard deviation. So here you can see that exponent to the x minus mu. So here the point mu is represents the peak, where the peak observed. So for mu equal 2, mu equal 4, mu equal 6, separate peaks observed at separate points. Mu equal 2, peaks observed. Mu equal 4, peak also observed. Mu equal 6, peak will be observed but having the same amplitude. Okay, so along this axis we consider the x values, and along this axis we have been considered the fx or the so-called PDF. Okay, so how we got these graphs? See, we have this distribution function. PDF is nothing but is your how much fx equal to 1 by sigma 2 pi root over into e to the power minus x minus mu whole square divided by 2 sigma square, right? 2 sigma square, this one. So here you have you consider that mu equal to 2, and sigma value is any constant. Suppose sigma value you consider any arbitrary, suppose 2, and here 2 pi is constant. And if you are going to be consider mu equal to 2, so you just put here mu equal to 2 and you just vary the x, then you are going to get this curve automatically. Okay, and if you are going to consider x equal to 4, okay, suppose this is your 0 and this is 2 4 6 along x-axis, and you just consider mu equal to 4 and sigma equal to 2, you just vary the x and you are going to get this curve. And then by considering mu equal to 6 and sigma equal to 2, then if I will vary the x value, automatically I will get this curve. Okay, if you do this in rough, you can found this curve for mu equal to 2 4 and 6. Okay, so now we are going to go for the normal distribution with constant mu. Here mean is constant, mu equal to 3, and standard deviation sigma we consider different, 0.5 1 2. So here if you are going to consider that sigma equal to 0.5, here you just put sigma equal to 0.5 and x equal to 3. So you are going to and just change the, or just vary, this is x equal to 0, just vary the x value, you will be get this curve. you can try in your rough. Okay, all other values are constant. See, here we have been considered sigma equal to 0.5, and this is 2 pi root over is a constant, e to the power minus x minus mu whole square by 2 sigma square. So x value you can vary from 0 to onwards, and mu you have been taken 3, and sigma already, here sigma already taken as 0.5. You just, if you are going to be find out all the values for each and every x value, you are going to get this curve. Okay, this curve. Now if we are going to increase this sigma value from 0.5 to 1, then what is going to happen? This curve is going to be spread towards left and right. This one, it will be spread. You can check by your rough by considering sigma equal to 1 for this equation, and vary the x, you are going to get this curve. Okay, that means its peak has been reduced but spreaded towards left and right. Likewise, if you are going to be increase further your sigma value, here we consider 2, you just write 2. Okay, if further I have to increase the sigma value from 1 to 2, then further its peak is going to be decreased from here to here, and again it will be spread towards right and towards left. How much it will be spread towards the left, that much it will be spread towards the right. And here you can see that this is your middle point, that is represented as mu equal to 3, and left hand side and right hand side of the curve, maybe sigma, for sigma equal 0.5, 1, 2, all the three curves are symmetric about mu equal to 3, or we can say that the normal distribution curve is always symmetric to its mean value. Okay, for you can see sigma equal 0.5 symmetric to about 3, sigma equal to 1 also symmetric to this point, that is your mean. For sigma equal to also symmetric to mean. Okay, now we have to discuss some important properties of normal distribution. So this is the typical normal distribution curve, where this point is nothing but called as the mean, where we are going to get the maximum probability. Okay, maximum probability. And this, along this axis we considered the PDF. So here the mean, median and mode are all equal for this distribution. That means this point is your mean, this point will be median, this point will be mode for the normal distribution. How it will be, we are going to prove in our upcoming classes. Here there is the proof that how the median of the normal distribution also will be equal to mean, that we are going to prove in our coming classes. Okay, and as we discussed that the curve is symmetric about mean. So about this is the mean, and this curve, bell shaped curve, exactly symmetric. Left hand side how much, that much you can found right hand side. Okay, so you just, if I am going to calculate the area, total area, left side to this point exactly same with the right side. Okay, total area under the curve will be 1. See, this curve is represents what, for each and every x value probability corresponding probability density. So at this point probability density, at this point probability density, at this point probability density, how much? Okay, so if I'm going to add all the probabilities, then always it has to be 1. So if I'll be consider the total area under this curve, so obviously it will be 1. So area under the curve is 1, or you can say minus infinity. This side is your minus infinity, this side is your plus infinity. While we integrate, if we integrate fx from minus infinity to plus infinity, then we are going to get 1. And one thing I forgot to say to you, that this distribution is very much important in the quantum mechanics, physics. In the quantum mechanics, it is very much important. Gaussian distribution, uh, Gaussian function has the much application in the quantum mechanics, because by using this distribution, we can represent the so-called particle, quantum particle. Okay, so the so-called quantum particle is nothing but like this: superposition of number of waves. So this is your quantum particle. This is nothing but the superposition of number of waves, and this you can see, this is looks like a what, normal distribution curve or Gaussian distribution curve, and this part it's a real part and this part it's a imaginary part. Okay, so this part is nothing but called as, you can say, the Gaussian distribution or gx function, and this part is your g dash x. In general, in our physics, uh, it is considered as the wave function psi x, and the other side is your imaginary part psi star x. So here the application of the uh, normal distribution, what I have been told to you. Okay, and other applications, that means I told that any dynamics can be represented with the help of normal distribution itself. Okay, so now area left and area to the right, the mean are same, that is zero point 0.5. So if the total area under this curve, if I'll be add, then if I'm going to get 1, and as it is symmetric about mean, that means this side is how much area, this side also same area. So obviously the area of left side is zero point 0.5, right side will be 0.5, so 0.5 plus 0.5 will be equal to 1. So area to the left and area to the left and area to the right about the mean are same, that is 0.5. Okay, now the maximum probability occurring at the point x equal to mu. So here x can vary from minus infinity to plus infinity, but at this point, this is the variation of x. Here x is what, x is the value of the random variable, values, different values of rv capital X. This is the x, small x. Okay, so at x equal to mu, we can get the maximum probability. Okay, we can get the peak, we can say the peak observed at the mean for the normal distribution. And how much that value, you just put x equal to mu, we can get the value. Here we have the distribution is this one. If we are going to be put x equal to mu, then mu minus mu will be 0, e to the 0 will be 1, and we are going to get the maximum value will be 1 by sigma into root over of 2 pi. So the maximum value, this peak is always, the value is how much, 1 by 2 uh, pi sigma into 2 pi, sigma into 2 pi. So solely it depends upon the standard deviation. Okay, okay, the maximum value we can get at the point mean, and the value will be this much. Okay, so these are the basic properties of the normal distribution. Sometimes it is asked in your exam, you just remember 2 to 3 marks it is asking in your exam, you just remember. Okay, now we are going to go for the characteristics of normal distribution. Here this is the characteristics curve of the normal distribution. If you can take the value, and if you are going to be try to find out also, you are going to get the same answer. Here this point is nothing but x equal to mu, that means this point is represents the mean value. Okay, and here we are going to be consider up to this much length your sigma. So mu plus sigma, this point will be mu plus 2 sigma, this point is represents mu plus 3 sigma, and left side mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. Okay, this point. Or if you are going to consider z, this is not the small z, this is only capital Z. if z will be 0, see, if mu will be x will be mu, then z will be 0. Z will be 0 if x equal to mu. So for x equal to mu, z equal to 0, right? And for uh, then z will be vary as, so if we are going to consider x equal to mu plus sigma, see, if we are going to consider mu plus sigma, then the z value will be how much? If I will put mu plus sigma here, mu plus sigma, mu got cancel, and sigma sigma got cancel, we are going to get the value is 1. So likewise, if we are going to consider x equal to uh, mu plus 2 sigma, if I am going to put, then z will be 2. Okay, likewise, like that. So here for x equal to mu, z will be 0, and x equal to mu plus sigma, z can be considered as 1, and for mu plus 2 sigma, z will be 2, mu plus 3 sigma, z will be 3. So here I'm going to say to one thing, that the normal distribution can be constructed with the help of either z or x. And here z and x are directly related, as this and this are constant. Okay, mu is the mean is constant, standard deviation is itself constant, so z and x both are interlinked, or you can say directly linked. So the normal distribution can be constructed with the help of either mu or z. Okay, so here you can see by considering any value of mu and sigma, you can found and you just consider the any mu value, any sigma value. Okay, and if you are going to find out the value in between these 2 points, the area under the curve is represents 68.26 percentage. See, as we discussed in the property, that total area under the curve is 1, that means 100%, right? 100 percentage. So here area in between these 2 points, this shaded area will be 68.26. Some books are written 68.2, some books are written only 68, and it will be after point somewhat it will be, the variation can be found in the different books. Okay, so here I written 68.26 percentage. How much? From this to this much area is belongs to 68.26. So as we know that exactly symmetric about the curve is exactly symmetric about the mean about this point. So 68 by 26, 68.26 by 2 is nothing but 34.13 percentage, 34.13 percentage. So this much is your 33.14, and this much area is represents 34.13 percentage. Okay, see this under this curve, the whole area is your 100 percentage, left side of the mu is represent 50%, right side of the mu under this curve is 50 percentage. But if you are going to be calculate by considering any value of mu and sigma, you are going to find out in between mu minus sigma, mu plus sigma, whatever the area, that area will be represent 68.26 percentage. So obviously this portion will be 34.13, this portion will be 34.13 percentage. Now if you are going to calculate in between mu minus 2 sigma, mu plus 2 sigma, in between this, okay, in between this, the percentage is your 95.44 percentage. That means if I am going to calculate this much, that is your 95.44 percentage of whole area. Okay, or you can say 95 percentage of the whole probability. Okay, so obviously you can see that this much portion already 68.26 we consider, we know. So and these two, in between these 2 points, the total area will be 95%, 95.44. So 95.44 minus 68.26 is your 27.18, divided by 2 is that this 27.18 will be how much? This area plus this area. If I will consider divided by 2, if I will consider, then this portion will be nothing but 13.59. This portion, this portion, this portion, this portion will be 13.59 percentage of the whole probability or whole area, you can say, whatever you can say. Okay, now if we are going to consider the area in between mu plus 3 sigma and mu minus 3 sigma, this, that means from point this to this, that area is your 99.73 percentage of whole area. So here in between these 2 points, the total area is your 95.44, and in between these 2 points, the total area is your 99.37. So if I am going to be subtract 99.73 minus 95.44, we can get 4.29. So the area, this much plus this much, is your 4.29, divided by 2, we can get 2.14. That means here the plus mark symbol area, this much, is your 2.14 percentage of whole area or whole probability, you can say. And this area, this small area, okay, this area is represents the 2.14 percentage of whole area, right? Now we have to consider beyond that. That means see, this much, see, in between mu plus 3 sigma, mu minus 3 sigma, we found 99.73. so rest of the percentage was how much? Rest of the percentage is your 100 minus 99.73. so 100 minus 99.73 is your 0.27. so rest of the area, whatever we have this side and this side, are shaded by this one, like this area. If I add this and this, it will give you the 0.27 percentage, 0.27 percentage. So divided by 2 is your 0.13 percentage. So this much area, this small area, is represents this small area. This small area represents 0.13 percentage of whole area, and this much percentage, this much area is represents 0.13 percentage of whole area. So this is the basic characteristic curve of normal distribution. So it will be required to solve the problem in our next classes. So here we have to stop our today's class. So in our next class, we are going to discuss that normal distribution as a limiting form of binomial distribution. That means from binomial distribution, considering some conditions, we can get the normal distribution. That means from PMF of binomial distribution, we can found PDF of normal distribution by considering some conditions or limitations. Okay, that we are going to discuss in our next class. So thank you so much for watching this video. Watch carefully and write down the note and ready for the next class. Thank you so much. Thank you.